I'll just briefly introduce Susan, and then we're going to have a discussion. So Susan is the Economist of Technology professor at the GSB. She's an economist by training. I met Susan for the first time when I was an admitted graduate student at MIT in the PhD program, and Susan had been a PhD student here and got her PhD in 3 years, very quickly.
4.
4 years? 4
you
years.
were 3.
I was 3 still, yeah.
Not that we're competing or anything.
Okay, but to Susan's credit, she started college when she was like 12, so it's, but I was an admitted student to the PhD program at MIT, and I went into Susan's office, and wow, was she just smart and curious, and in fact, I think we started our first research project more or less on my admitted students' day. And so I've had the great pleasure of being on the faculty with Susan for a long time, first in economics and now here at the GSB, where she got here first. And we're going to have a discussion. I'll just briefly, to foreshadow a little bit, you're going to hear a little bit, we're going to talk a little about Susan's career. And you'll see she's had a very interesting trajectory, starting in academics, going out into the private sector in a variety of ways. And for the last 2 years, she has been the chief economist for antitrust at the Department of Justice, which she's done while also having some of her time still here, working on various things at the school. And so she just rewrote the US merger guidelines. She's been in the middle of all of the interesting issues around market power and technology. So we'll get to that as we go on. Okay, Susan, great to get to do this with you. Maybe to start out, you could just say a little bit about how you got into academics and became a professor.
Yeah, so I went to college at the late 80s, and I had always been a bit of a computer nerd. I was programming in BASIC on our little TRS-80 Radio Shack computers and so on. And I needed a work-study job, so I ended up getting a job administering the Unix workstation for this economics professor. And he said, well, I kind of want to hire someone who wants to get an economics PhD. And I was like, yeah, right. I didn't really understand what that was about or what being a professor was really about. But at the same time, I had a summer job working for a startup, and we were selling computers to the government in procurement auctions, okay? So we were writing bids and putting them in these procurement auctions. And at my startup, everybody was complaining about the rules. And people were like manipulating the rules. And it was unfair, and it was inefficient, and it was frustrating. And we sat around, and we drank a beer and complained about it. I told my professor about it. And he showed me how to turn that problem into an economic analysis of the policy and the incentives. And he ended up testifying in front of Congress to try to change the rule. And so that was like, wow, here's this tool. I can take this job, and I can change things for a lot of people. So that was what got me excited.
And you came to the GSB. You were a student. You're in the PhD program. Talk a little about being a PhD student here at the GSB.
Well, first of all, actually, the GSB was a great place to be, and we were right there before the beginning of the internet, so that was a wonderful time. I spent a lot of time with MBAs because I wasn't quite 12 when I started college, but I was 20 when I started my PhD, and so I was definitely up for the LPFs rather than the board game nights. So that was good. But so it was an exciting time to be here. And there was a lot of interest in things like auctions, and that was one of the reasons I came here, because Milgram and Wilson, who later got the Nobel Prize and were faculty members here, were innovators in this area of auctions. So I started working on sort of slightly more theoretical work, but yet, at the LPFs and in the corridors and at in the Raines housing and so on, people were also like starting to build things like Yahoo and eBay. And so I also felt this a little bit of like the path not taken, because I was doing very well on my chosen path, but yet this whole startup computer thing was sort of getting left behind, even though that had been my initial passion. But nonetheless, I put my head down, and I got the job at MIT, which allowed me to recruit some young students like you.
Okay, so you started off, you go to MIT, when you started, you did very mathematical research in economic theory when you started. And then at some point you sort of broadened out and just started exploring all different things. How did you pick the things you were going to work on as an economist?
So actually, looking all back on it, the mathematical part was almost an accident. I've always wanted to solve problems, and it just so happened that I proved these theorems that helped people solve some problems in economics, but it was very upstream. And frankly, it was a little bit less satisfying to me. So I was very happy to kind of start getting back to solving more real-world problems. And so like some of the things that we worked on, we were combining economic models with data to answer marketplace design questions. So we were asking questions like, we were looking at whether having small bidders around helped make the auction more competitive or deterred collusion. And then we combined data with models to answer questions like, how would you design an auction to both make sure the small bidders won enough to keep participating, but also didn't raise procurement costs or cause inefficiency? And so I guess in these kinds of problems during that time period, it was about, how can we use these really rigorous tools, but solve policy problems directly?
So after you had been, I guess, first at MIT, you came back here as a faculty member. I guess then you went to that was one of my big losses in the economics world when Susan left and went back to Harvard. That was terrible. But we did bring her back eventually. You went back to Harvard, and you had won the John Bates Clark Medal as the leading economist under the age of 40 in the United States. And then you did something a little unusual, which was you decided to go to Microsoft to be their chief economist. Why did you do that?
Well, yeah, so I was kind of sitting in my office at MIT, and I had been mostly working on timber auctions and other types of auctions, kind of old-fashioned stuff, but I had started working on search advertising auctions. And I got this big prize, and Steve Ballmer had read an article about me in the Harvard Alumni magazine. So I really didn't know much about any of this, and I just got an invitation to come to Seattle. I was like, okay, I'll go. So I went, and this was in 2007, and they just tried to buy DoubleClick, which Google bought and turned into Google's ad exchange, and then bought this other company, Aquantive, for $6 billion, which they later wrote off entirely. And then it was like the next week that he read the article about me, and it's like, I think I should use some different advice. So they brought me in, and this was pretty scary because I was just coming in cold. I hadn't really been in a business meeting since I was in college working for the startup, and certainly never something like Microsoft. But they had these really interesting questions, like, can there be more than 2 search engines? And what does that look like? And should we be in the advertising business? And how would that work? And also, how do we operate it? Because they had built a search engine, and they had engineers making kind of the user side run, but they didn't have any analytics on their ad platform. So they were kind of at a very, very early stage of understanding big data. And building packaged software is incredibly different than running a search engine. So they just generally realized that they were kind of in over their heads a little bit. So, but I just kind of got thrown in there cold, and it wasn't, I was just consulting, and then suddenly, like, I was chief economist, sort of felt like the next day. And I was, is Yahoo worth $35 billion? And, it was kind of the big time. And that was pretty overwhelming. I think if you'd asked me if I wanted to just go do that big job, I probably would have said no, but I got sort of, as soon as I saw what it was involved, I realized it was as intellectually challenging as anything I'd ever done, because I was trying to predict industry structures for industries that were new or didn't exist yet. I needed to understand the value of data. How many more advertisers would you get if you got more users, and so on. So these were incredibly interesting problems. But so that was, so it was pretty compelling to have, and since they were early stage, I had a very large influence very quickly. On the other hand, there was still like this connection with research because I was seeing research problems every day. In fact, I still haven't finished all the research ideas that I got in 2008. Because basically, I had a front row seat to what we now see all around us, but you could sort of see the future. What is it like to try to manage a large artificial intelligence machine learning system at scale that has 2,000 algorithms and a decentralized structure? How do you know if it's safe, and how do you make decisions, and how do you monitor it and make sure it's giving users what they want and what they expect? You have this really decentralized advertising business with, some of your customers are really small businesses, and some of them are, companies like Amazon and eBay are advertising customers as well. And how do you manage a system? Going back to our work on like the small bidders and the big bidders, but now this was much more complex. How can you make a healthy marketplace where the small bidders stick around, but you don't lose the business of the big businesses either? So those were like more economics-y questions. But then there was all these other things too. Like, wow, this affects what information people get. And we re-rank the results, and people click on different things, and they go to different websites. And wow, what if people start getting their news this way? What will that do? Okay, people are like, oh, okay, that's not how people read the news. People like their newspaper, Susan. What are you worried about? Well, like I was worried, and I was right to be worried, just a little ahead of my time. And then, the A/B testing platform is another thing, right? So at the time, economists occasionally ran randomized experiments, but it was like group 1 and group 2, and you would spend a couple of years planning it and analyzing it. Like how does class size affect student outcomes? But the idea that you're going to run thousands of experiments in parallel and then be implementing hundreds of things at the time, mind blown. And the science of how to do those experiments and how they're different when you have large data sets and you might use the data for personalization. That science hadn't been done, the statistical science, and so on. So there was suddenly both this incredible opportunity to do it and play with it, but also it opened up a bunch of scientific questions. So while I was there, I was seeing the questions and I was kind of hacking the answers, guessing at what an answer would be and implementing something that would be 80% good. But ultimately, what led me to leave and come back was that I realized that I'd just been given this enormous gift because I would go back to my office at Harvard and say, hey, there's A/B tests, there's machine learning. They're like, machine learning, we don't do that. A/B testing, what are you talking about? Search engines, that's niche. Like, who really cares? Like, that's the economic of the internet. That's like a tiny little thing. So very negative feedback, which at first was discouraging. But then I realized, wow, I can really make a difference. I can take that knowledge and be a part of like integrating what's coming into the fabric of our teaching and our research.
All right, I want to just go a little more into that sort of feedback loop between going as an academic into industry and then kind of coming back. What was the most, you sort of went in first to Microsoft, then you were lots of technology boards and other companies as well over time. What's the most valuable thing you have brought into tech companies as an academic?
It's a great question, and sometimes I wonder, why do they want me here again? People seem to want me here, but I don't always know why. So I've puzzled over, what economists can do. And by the way, one other thing that came after that was really the beginning of this career path of tech economists. So we started these little groups with like 3 or 4 or 5 tech economists, and now we have a conference with 800 economists come, and there's a job market and everything for economists to be part of the tech industry. So I've listened to other people talk about this question as well. I think there's more than one answer. I think at the highest level, like some of the things at Microsoft, I'd say one of the things I'm really proud of there is I worked on convincing the company to build Azure. And that now it seems like a no-brainer, but that was highly controversial because there was this business, Microsoft SQL Server and tools, And that was making billions of dollars a year. And the people who ran that business believed that now and forever, their customers were going to keep doing what they were doing, which is doing everything on premise. And if you ask the CTOs and the CIOs, they would all say, oh yeah, we want to be on premise. We have to be on premise. Because they were running organizations that way, right? So we did a lot of economic analysis for 2 points. One was to think about the cost curves and say, okay, those CIOs are going to get fired because their costs are going to be 10x what can be delivered. So that was one very important fact. A second really important fact was to think about the industry structure and to realize it was likely to be concentrated. And so instead of like wait and see if this cloud thing is really going to be for real or not, and then we'll build it later, no, you needed to build it now, even if it meant sacrificing, a couple $2 billion of certain revenue for an uncertain future. So that was a really gutsy decision. And so we did a lot of analysis. We argued about it for a year and a half or so. And then Steve put Satya Nadella, who was in search, in charge of server and tools, which he then turned into the Azure division, which was, again, very controversial. But one other piece of that was Satya and I had been working together in the search engine, and we both had this lived experience of what it meant to be a customer on the search engine. But so when I think about like what did I bring to that conversation, obviously there were very important other participants in the conversation. But I would say like the rigorous economic analysis and understanding the technology well enough to be able to sort of predict the future, and also understanding how the features of the technology and the features of the business model were going to fit together to lead to a future market structure, which made it imperative to build immediately. So I think having that rigorous thinking is important. And I think more broadly, and I think this is something that's common across business leaders as well. When I say, like, why is it so important that we train future MBAs to be in the room? At Microsoft, there were lots of rooms where there were no MBAs. Like, I was kind of doing the MBA job, but the MBA wasn't in the room, partly because they didn't have the technical background. And so I wanted to make sure that our future leaders were being trained so that they would be in the room. And so, because I feel it's so important to have that kind of the business perspective, it seems so obvious, but when you're building technology, you can have people trying to operate a search engine, and they were building tools for advertisers. They'd never met an advertiser. There were engineers, like this was just number 1, 2, 5, 6, 7 in the database. Their customers were just lines in a database, and they didn't have the insight about the business problems. So I think, and it's not that hard to become multilingual. So you have your domain expertise, but you become multilingual and grow up with it. And so as decisions get more data-driven and so on, I wanted to make sure that we were teaching our students, and part of it is just exposure. So getting exposure in the classroom to technology so that it wouldn't be frightening, and people would have the confidence. Also the confidence to raise your hand and kind of call BS. Like, people have these technical visions that are, kind of crazy. One of my big jobs at Microsoft was to say ideas were bad. It's kind of depressing, but, technical people can come up with lots of ideas without really thinking through whether the business is viable or not. So that's kind of I think, a value. It's very similar to the value that a business person brings. It's really combining the technical with the business insight.
I love that. I think that's a core learning in an academic seminar, is being able to tell people their ideas are bad. So that's good you were able to apply that. Now, one of the things you brought back from that experience in technology was an appreciation for machine learning, which was kind of nowhere in economics or the social sciences when you started working on it, and now it is like at graduation when the PhD students at the GSB walk across the stage, like, machine learning is in literally every person's dissertation title. Say a little bit about how you saw that coming and what you've done with that to make it such a big thing.
Yeah, so one thing that you may or may not know is that generally economics research and marketing research and so on the research side has been empirical for a long time. So we've used data together with models. But a lot of our research was on small data sets. That's one thing. The second thing is that economics and business research is often about policy questions or like cause and effect. So we want to know what would happen if a firm raised prices. What would happen if we increased the minimum wage? These are like what if kinds of questions. So the first wave of machine learning and AI was all about prediction and classification. So you have a data set of images, and you have labels. This is a cat, this is a dog, this is a horse. And you then hold out some test data, and you use the model to tell whether a new picture is a cat or a dog. And you know you've done a good job if in this hidden test data, you predict cat and dog, and you get it right. Okay? So that's a very easy problem in a way. It's a good thing you can delegate to a black box, because if you just hide it's like hiding your answer key in the drawer, teacher's drawer. You have an assessment, and some intern can come in and build some black box thing. You don't need to know how it works. At the end, you just assess, like, did it get the cats and dogs right? If it got it right, great, let's go. Okay? So this is, of course, the engineering side of it has been miraculous, right? But the conceptual side of it, like what is the problem you're solving, the statement of the problem and the ability to assess where you solve the problem is very simple. You can contrast that with like, okay, what would have happened if we hadn't cut the price last month, if we had kept it high? What would happen if we introduce this new product that's kind of similar to our old product? What if we, announce a promotion? These are all kinds of these what-if decisions, and you can't see the world if you hadn't done the thing very easily, so you don't necessarily have your answer key in the drawer. If I'm treating patients with a drug, some people got the drug, other people didn't get the drug, but anybody who got the drug, I don't know what would have happened to them if they hadn't. So that's a causal problem. So one of the things that the gaps that I saw was that these amazing engineering innovations had not been connected with the set of people doing regular old business analytics and kind of economics research. So I built I laid out sort of the conceptual framework and built the tools for sort of connecting those things, which helps you, for example, to build a personalized policy. So you give the drug to the people for whom the drug works best. So the tools and software I built are now, like, they've been used by thousands of social scientists to, people go back and reanalyze old experiments, or they look at administrative data. Some things I've looked at are like the effects of layoffs on people and who's most resilient to layoffs and who's most impacted. But also tech firms have adopted this as well, and they built them in the A/B testing platforms. Many of the large tech firms and small tech firms have used this. I meet people on the street and like, oh, I'm using your software package. And so, of course, how did I know that would be adopted? Because I was working on it in industry, and I saw that the products didn't exist and that people were confused about what they should do. And so there was a problem I could solve, and I went out to solve it. But beyond that, I also kind of proselytized to academics about the impact of this stuff and that they needed to learn about it and sort of measure the impact as well.
And then when you were part, a couple of years ago now, but must have been 7 years ago now, you were part of the group that set up the Human-Centered AI Institute at Stanford. So tell us a little bit about that and what you did there to help. This is an institute at Stanford that was started 2017, I guess, about 7 years ago, with a vision of advancing research in artificial intelligence, sort of foundational research, but also application and ethics. Thinking about the responsible use of AI. So maybe you want to say a little bit about the role you played there as sort of the social science person in the team.
Yeah, so I think one of my learnings from the past had been that people it's really hard to just tell people to be interdisciplinary. It's hard to just say, hey, you engineer, go talk to you ethicist. People are like, yeah, I'm busy. But if you are actually building something together, or if you are really more deeply engaged in the problem, that's when those collaborations happen. So that was something I've seen at multiple tech companies. It's when there's a problem. Oh no, what do we do? People are putting in objectionable search terms in the search engine, or there's something that's causing a differential impact on different groups in your products. That's when people make a lot of progress, because the engineer, oh my gosh, I don't know how to solve this problem. And the ethicist or the business person is, well, okay, I don't really know what the options are to try to solve it. Content moderation is another great example like that. It's so hard. We don't know, what it is. Like, people don't agree on what you're trying to do, and then how would you measure if you were doing it? So these are big challenges. So based on that experience, I felt like at Stanford, if we wanted to send people out to the world, we needed to really get them engaged in real problems. And that's why there have been a bunch of institutes started at other universities, but ours is more inherently multidisciplinary. And so just from, what is one of the problems I wanted to solve, our engineers in the computer science and engineering school, they would take all these classes where they would learn machine learning. But what did they learn? They would learn an algorithm, like random forest, and then they would download 200 data sets and run it on all 200 to see how it worked. But they didn't know what the variables were. They had no idea whether this was like a health data set or an advertising data set or anything else. So they were getting really good at sort of cranking the machine, but then they would go into industry, and at the time I was on tech boards, and they'd say, oh, those annoying Stanford grads, they're coming in and they want to build neural nets for everything. But wait, we're a lending organization and we have regulation, and what if the economy changes? Will your model break, right? So these students were hot on the job market. They could get jobs, but it was actually hard for companies to ingest them. And then on the student side, actually, they also kind of realized they had something missing. They knew neural nets would get them a very high-paying job. Okay, but like, they also do care about the problems they're working on, and they realized that they didn't know, they weren't getting trained for that. So this is kind of the gap that we were trying to solve. Let's let the engineers solve a real problem and actually get practice thinking about what it means, and let's also bring in social scientists or business students and let them kind of learn from the technologist about what solutions are possible.
Yeah, and the Institute's been amazing in doing exactly that, including with classes and other programs. I want to open it up to the audience, but before I do that, I want to ask you a little bit about the DOJ experience. So 2 years at the DOJ, you rewrote the merger guidelines. I know you can't talk about prosecuting all the tech firms, but that's been a big thing, of course, and you help sort of you've been helping to bring the DOJ into a data-aware era. Say a little about the things you're most excited about from the work you've done at the DOJ.
Sure, so the merger guidelines was a big deal, and that was a really complicated project. Just to, very simply, the previous guidelines there were many cases they didn't cover. And that can be a problem if you're doing a merger and the situation that you're in are not addressed by the guidelines, because then you have to sort of guess about how the agencies will think about it. And then the guidelines are also helping staff do investigations. And so then they're kind of unmoored in terms of, what's the language? How do I approach this? And so one of the things that was missing was a merger involving a company that's already a monopolist buying an adjacent product. Not Coke and Pepsi merging, but a firm buying something that might be a complement to their product, but it might also be a complement to their competitor's product, okay? And then they might be able to withhold that product from their competitor or reduce interoperability. So we did have already analytic frameworks for analyzing that in the case where it's a pretty competitive industry. And so if things are very competitive, then one firm buying a complement can be beneficial, because you realize that if you sell more of your product, then people will buy more of your complement. But if you are a monopolist already, the main thing you're worried about, and you should be worried about from your shareholders' perspective, is not losing your monopoly. Okay, so you're not going to care so much. You're not going to be thinking about buying something because of some short-term effect. You're really thinking about building your moat, or whether this complement might help somebody enter your industry. So those are those kinds of considerations. And so in the merger guidelines, the revised merger guidelines, we laid out how we think about those things. So it's still all about, in the end, how a merger is going to affect customers. But it's not just today's customers assuming that there's going to be lots of entry. But it's also about tomorrow's customers who may lose out. So, if you're a monopoly software company and you buy something adjacent, maybe you just end up bloated with bad customer service and buggy, and you have no reason to fix it. And so we're thinking about tomorrow's customers who are cursing at the screen and don't have any other option, rather than just, are you going to get, a 2% price change today? So it's really introducing those dynamics. Now, what's interesting actually is that here at the GSB, back in like the long time ago, 70s, 80s, research was getting done that talks about all those kinds of scenarios. So the research is actually quite old, but the antitrust law is very conservative and it moves very slowly. So it had mostly been still considering a world with like perfect competition and kind of atomistic companies. And it was also really considering worlds where the only choice a company has is to either lower price or improve quality. So if that's your only choice and a competitor comes in, of course, you lower price or improve quality to compete. But if you have other choices, like closing down your API, that's not in the Econ 1 textbook, and that might be good for you and bad for your customers. Okay, and so those are the types of considerations that we brought in. From the building up the data perspective, actually, it's really, I think of it just a continuation of the theme. So, here at the GSB, I built the Gold Capital Social Impact Lab, where we have interdisciplinary teams, business students and engineers, building stuff for social impact or helping social impact organizations adopt technology. The government has that problem in spades. They have, like the DOJ, my group used to have economists and lawyers, but now you're investing tech firms. You're getting huge data sets. You can't even ingest them. So all it has to get outsourced to consultants, and it makes for more expense and lower quality decision making. So one of the things I did is I built a data science team, I'm building a technology team, and getting the software tools, and so that the agency has more expertise. And also, when a company comes in, they understand what they're talking about, they understand the vocabulary, they can get to decisions faster and ask more intelligent questions. So that's a work in progress. But I would say it's interesting, that's happening actually all over the world. And I think with the AI revolution, all the regulators around the world are really scared that we're going to have this super important technology, and there's going to be like a couple of dominant firms, and that's going to really slow down the benefits. It might hurt the application ecosystem. It might hurt the ability of startups to be able to invest in that. So having in-house people who actually understand the technology and can build it themselves and really be fluent in it is crucial for solving that. And I'll give a little plug. We're having a conference here. The website just went up today. May 30th, a conference DOJ and Stanford jointly organized at the GSB for studying bottlenecks in the AI industry and what we need to do to promote competition. So we'll have startup people and people from small and big companies to hear about competition and issues in AI.
All right, so I've got to ask you one more question based on that, which is, I think one thing you brought in to the DOJ and to write the merger guidelines was a lot of antitrust and regulatory policy historically really envisioned kind of traditional economic widget manufacturers making, and the real question was, were there 5 firms or 3 firms or 4 firms or 2 firms and so forth, and the market was sort of largely contained.
By the way, it's a term of art at the DOJ internally. We're like, oh, that's a widget merger.
A widget merger, okay. And that is a term of art in economics. And you kind of brought in a frame that, no, the modern economy is much more about two-sided marketplaces. It's more about network effects. There's opportunities for monopolization and different kinds of barriers to entry, and and different ways in which you can exercise market power. If you take something like artificial intelligence, which is absolutely in this sort of modern way of thinking about markets and competition, what do you think we're going to end up with 1 or 2 dominant firms that are our technology overlords, or is it going to usher in an era of more competition?
Well, so I am trying to learn everything I can about that topic, and I think all of the competition people in the world are trying to learn everything they can about that topic. And there's certainly, what I am hearing are multiple perspectives. Some people are very worried that there's firms that already have a dominant market position are going to buy the things next door. They're going to make exclusives. This thing, it's so capital intensive. It seems like, gosh, we're just going to see some of the current problems we have just replicate themselves, only worse because it's even more important this time, right? It touches even more of society now. On the other side, there's, right at this very moment, a lot of people are using open source large language models. They are fine-tuning them. They're doing something called retrieval augmented generation. Basically, like if you aren't into the technical part, these large language models, they take any sentence or paragraph or paper, and they boil them down to like either 7 billion numbers or 70 billion numbers or something like that. So it's like a coder ring, a coder or decoder ring. So any words get a code. And so what the retrieval augmented generation does is say you have documents in your company. You just run all the documents in your company through this coder ring, and each document gets a code. So now, instead of having documents of text, you just have a list of codes. Long codes, but codes. And then when somebody in your company has a question like, oh, is there a presentation about this? Or, what's our analysis about that? That also gets turned into a code. And then you take that code and you find the documents whose codes are most similar. And that's step one. And then step two is you ask a large language model to summarize those documents. But also you can tell them where the original documents are as well. That's actually something that's very easy to do. You can do it, for $1,000 or $2 of compute, more if you want it to be bigger models. But I've done it myself here. A lot of professors have done it using Stanford equipment and so on. And then running it just takes like 1 or 2 GPUs. So it's something that can be done once you've trained it, which is a little more expensive. Then it can be just done on a couple of computers. So that's something that's like, wow, okay, like this is going to be super competitive, right? Like if there's an open source model and anybody can do it, it only costs a couple $1,000s. I can do it with a master's student. In my whole career, I've built stuff. Most of the time, you think something's going to work in 6 months, and it works in 2 years. This thing, I'm like, hey, guys, I have a presentation in 10 days, and hey, master students, can you like try to give me a demo? And it worked. In 10 days. Of course, we had the data all organized and stuff, but it's like, wow, like nothing has ever worked that fast in like my whole life. So this is something that seems like super competitive. But that's just because today, fine-tuning the open source model is about as good as the thing you pay for, and it's also good enough. Now, what happens if the thing you pay for is a lot better than that? And also, what happens if those open source things go away for whatever reason, either because companies stop building them or because they're deemed to be unsafe? So this discussion, that's just one element of it, like open source large language models. That's one thing that could really affect the competitiveness of the industry. But there are other bottlenecks. There's the chip bottlenecks and so on. So those are the kinds of risks that we're worried about.
And just to make sure I understood, with that model, that type of architecture where you're doing retrieval, that's a way to do generative AI, which we've all seen in OpenAI, ChatGPT, and index back to the underlying documents, like Google search. So that's a hybrid type of technology.
Yeah, it's similar to what you're seeing on Bing. If you try Bing right now, they'll give you an answer, and they'll also give you the citations. But so you can build that for your own company relatively easily. And I've basically never said anything was easy before. Like in my entire life, basically. Usually people come ask me, oh, should I adopt this? And I'm like, not really. We had a team of 10 engineers, and it took them 2 years to get it to work, so probably not. But like this is the first one, like, yeah, you can do it. And then now the only question is just, so does it somehow become obsolete by the latest generations of the things you pay for, where you decide it's not worth it to build yourself? So it's a really interesting like horse race between these two models and what's going to be the most economical. So it's like, wow, like this is a moment, again, we're having a moment where like this industry could go one way, say at the beginning, like we all thought there was going to be 10 search engines, like there was the day, and then, now we think there could be a really competitive industry, but it's, it could go either way.
Okay, next question for Susan. In the back. Not quite in the back, but almost in the back. Yo, yes.
Hi. I'm very excited and impressed that you managed to get a team working in the DOJ of engineers and data scientists. How could we do that like 50 times bigger across the whole government?
That is an excellent question. So I have learned so many things are hard. Believe it or not, the very hardest thing is like just getting software, and cloud computing has made things easier, but it's just really hard to get stuff in. So one thing that's really surprised me about government, and by the way, in my previous life before I went, I was on boards of companies who got frustrated with regulators, so I do understand the frustrating side as well. But I'm just here going to focus on the positive. That people are so mission driven. Like I thought, how am I have seen these tech companies. I was on the boards. We were trying to hire people. You couldn't hire anybody to save your life, and they stay for a year. How is this government ever going to hire anyone? And like for less than $100,000 a year, never going to happen. But it did, and the first time we had 3 data science positions, and we got our top 3 choices, and I couldn't believe it. And why? But one thing is that people, they really, especially young people today, they really value the mission. And there's a lot of people who are concerned. They've had personal experiences. This is actually something else in the merger guidelines. We got 30,000 comments from individuals. Part of it, the Hollywood writers were on strike, so we got a lot of them writing in at the time. But we also got thousands of comments from nurses and doctors now. Again, these are folks that didn't used to think of the government as their friend, but now they've been bought up by, they've been consolidated and consolidated and consolidated again, and now patient loads are doubled and they can't treat their patients right. And so there's just a lot of people who have been personally touched by competition issues, and they're very passionate. So they're really excited to go and work. I'm not going to go, use my time and effort to hurt people. I'm going to help people. I worked on targeting ads at some point in my life, but I don't want to target ads. I want to help citizens. I was at a retirement party a couple days ago where I was speaking, and hearing the people talk about why they had come and why they had stayed, and you really saw the values. Everybody's like, I'm working for the American people. That is what I do. So. That's part of it, is just that now I understand what it takes to recruit people. We are getting sort of younger people. The other thing, though, is that actually we're a pretty good job, because we're flat organization. There's me, and I'm a political appointee, and then there's a staff member under me, and then we have a manager layer, and then we have the staff. So the staff, even this right out of school data scientist, is playing a huge role in an important investigation, and they're the domain expert, instead of being the cog in the wheel at the bottom. So those things have really helped. One other thing, we're hiring technology policy, and some of you might know people who would be interested in this. There's also some career changers. There's people who made a bunch of money. Maybe they got in early, had equity, or their spouse, and in tech or other places. And I was hey, I see that there were some negative societal impacts, and I want to do something now. So we also see VPs changing jobs and coming to a lower salary to try to work in government or government policy.
Yeah, great answer. That was fabulous to hear that. Okay, there's so many. Kara, you just decide.
Hi, my name is Pratibha, and I've been fascinated with this talk so far. I have a question around your work with the DOJ. What are some of the future crimes related to AI that you are most concerned about?
Yeah, so I was mostly talking so far about competition in the AI industry, but there's also the question of how will AI affect competition and the practice of competition. So I think we have a real challenge, actually. One of the things the merger guidelines did is they reverted the concentration thresholds for blocking mergers back to what they had been for the previous 40 years. They had been temporarily relaxed in 2010. And I think one thing that made me feel like the older thresholds were more important, were more appropriate, is that in the old world, collusion required, you had to like sit down in a room and to travel and try to talk about things. Now, we're going to see more tacit collusion, which, depending on how it takes place, it might not be illegal. It might, but it might not. But you just have, you have algorithms setting prices and looking at the other prices and responding to them. And research has shown that it's pretty easy for those to learn to keep prices high. And so industries where like humans were occasionally changing prices might have been less vulnerable to collusion than industries where the two robots are learning to collude. So I'm just worried in general that we're going to see, with moderate concentration, these algorithms kind of just lead to higher prices and higher markups. The second thing is that there can be algorithms or technology that are essentially helping people collude, helping them share information, information that wouldn't otherwise be public. And so, there's, and that can, in principle, again, lead to much higher prices. And there's a couple sectors where that's becoming more prevalent. So those are some of the things that I'm worried about. The one where the robots are just like, I build my robot, you build your robot, we do it completely independently, but they learn to set prices high by reacting to each other is a harder one to get at. And so we may have to update regulation to think about like what does responsible pricing look like. But frankly, I don't know how to write that regulation. That's like pretty hard.
That's a fascinating problem. Okay.
Hi, thanks. I guess sort of two quick questions. One you sort of hit on, but should the US government be competing with OpenAI and Grok and Meta? Should they be writing their own open source LLM utility? And then second, you've been on boards of lots of marketplace companies, Turo, Expedia, Lending Club. What are the biggest and most common mistakes that you've seen from tech companies as they build and grow marketplaces?
Actually, let's take the second one because we haven't talked much about that. And actually, one other thing I should have mentioned really is that my time at the GSB was also an incredible learning experience on platforms. And I've been teaching about platforms and marketplaces here for a long time. Those were popular courses. They've only gotten more popular. And it's another place where economics is really helpful. Most of the time you think, oh my God, I slept through my economics class. Why is anybody signing up voluntarily to take an economics course? But if you're going to build a marketplace, like you really do need to understand some economics. It's not so easy to manage suppliers and buyers and make them healthy. So I would say one challenge is it's actually just hard to know and hard to measure whether your marketplace is healthy. Like, should I spend more on advertising to get more Uber drivers, or should I be trying to get more Uber customers? And sometimes it's way out of whack, so you should lean into one side. But a lot of times these markets are very, very local. So how do you, at scale, understand where you need more supply? I think one of the biggest mistakes I see marketplaces make, and this is also related to A/B testing as well, and mistakes in A/B testing, is that it's very easy to test the user side. You can change the interface, they click a little more, move it this way, they click a little less. You can run an experiment in a day and sort of figure out whether it should be pink or blue. Okay? But on the supplier side, people are often running businesses. So like on Turo, they're running a little small business renting out cars, or you might be a property manager on Airbnb. You may be an advertiser. So those small businesses are, actually, if anybody sells to small businesses, you'll know, like working with small businesses is really hard because they're like not irrational, they're not like completely short-sighted, but they also don't have a lot of time to adapt to your new tool, and they're a little bit unpredictable. And they're hard to attract, they're hard to sign up, there's a lot of frictions. So the biggest mistake I think that marketplaces make is because they can't measure it very well. Their A/B tests show them as being unresponsive to anything. They don't really appreciate how important it is to actually to nurture the supply side, to make sure they understand the businesses of their supply side, to build tools that make the supply side easier, because you can't measure the ROI quickly. But yet, if you have 1 million suppliers on your platform and you can save each of them, one intern can save each of them an hour a week. Like, that's massively efficient. And so if you think about, you're creating this huge amount of surplus, you just can't quite measure it. But if you're capturing even like a tiny fraction of it, of course the intern is worth it to fix the bug in your supply side software. But across the board, every marketplace I go to, you hear people like, oh, we can't get the resources to like fix the bugs in the seller tools. But there's all these resources making the user interface like fancy and flashy, right? So that's I would say, a pretty big mistake. AI is now going to come into that because we're going to see these marketplaces using AI to help make their supplier life easier, to help the suppliers manage their business. And at these conferences, AI conferences, I'm seeing it's like Salesforce and Stripe and so on. They're the ones building AI at scale on behalf of their customers. And so it's going to be really interesting, I would say, to watch those spaces to see this intersection of like marketplace and AI.
Susan, thank you. That was amazing.